All right, here we are. Welcome, welcome. Adjust some levels. Make sure we're all good. Hey, there we go. Bum, bum, bum. We got the mic going. All right. Hi, welcome back. If this is your first time tuning in, and God, that's such an old term, tuning in. Anyways, if this is your first time watching, how you doing? I'm Agent Ultra, and on this stream I build software and just hack on things and learn stuff using the programming language Haskell. So we've been working on for a while now, learning about wave function collapse and how to implement it. And mostly following a guide that's actually written in a very procedural way. I think we're getting close to, we're just kind of like in the weeds, getting our stuff working here. So we got most of the code for it. There's just some kind of problems in the translation from the guy that I've been working on. I'm implementing an algorithm written by somebody else to try and compare against my original attempt at it to see if I can figure out and learn more about how this algorithm works. And maybe if I can go back and do it in a more functional way, that would be nice. But yeah. So if you don't know what wave function collapse is, it's a procedural generation algorithm that's like mainly used for generating like textures, or in game design and game development, like for generating random looking levels. You basically give it like an input texture or an input set of rules, and you can generate a larger texture from the smaller input. That is kind of self-similar in a lot of ways. So we're going to set up the builder here, the test runner, with fast and the file watcher. Right. Okay, cool. So there we go. We got something to work on here. We can't find the pattern to collapse to, so we were working on this last week and ironing these out. This is a little bit of progress in the errors we started with last week, so we're getting close. So let's go find that one. That's here in the Go function of, I think, collapse at, yeah. So this function is trying to find a sort of semi-random way of picking a value to collapse to. That's what it's doing. Right, it's based off of this one here, grid bugs wave function collapse. And yeah, this part. So this is, I think, probably one of the things that's a little bit hard about trying to do or learn algorithms in Haskell is that a lot of algorithms are written in very procedural, imperative ways in procedural languages, which can be pretty challenging to translate into Haskell. Not impossible, but challenging. And I don't know, I was having this thought after the end of the stream last week that maybe this is one kind of area where people new to Haskell, and myself included, get kind of into and kind of bang their head against. And it can be very daunting sometimes. So if you find it challenging, don't worry. It is for reasons, because in some ways procedural algorithms are easier to reason about in some ways, but not all. And they can also be really hard. So, yeah. Although I was reading a functional Perl by Bird on solving Sudoku, which is a similar-ish problem, and he had some pretty wild ideas to try and get like an influence on like how would I do this functionally instead of using such imperative style code. Anyway, so for possible tile index in possible tiles. So this list here should be our possible patterns, I believe. And we call go. Pick pattern. We get the possible patterns. We sell possibilities. And let me know if this music is not a good mix. Any hoozle. Possible patterns are taking the array with the indices, the association list in the array, filter on the second, so just the active ones, and then we just take the key. So the pattern indices. So just taking the active ones. Right. The possible choices we could have. That's what I'm assuming this one means. All right, remaining is an integer between the sum of possible tile weights and 0. So that might actually be not right. And well, that maybe it is. Total weight. Yeah. Okay, I think that's probably right. And then you get the relative frequency, you get the weight. Hints. That's just getting the frequency hints, because we need those to calculate relative frequency. Hints, right? T, okay. That's our possible tile index. Right, P, possible tile index, okay. And then if remaining is greater than or equal to weight, modify it. So we're using mutability here. Otherwise, we return the possible tile index. So we're flipping this around here. We're saying if remainder is we should say greater than or equal to weight, or less than weight. So this would be greater than or equal to. This, and then the remainder minus weight. That's minus equals weight, and P's on the rest. So then we go to the next one. Okay. So then we're probably initializing to the empty list. Alright, that can be a thing. So there's a quick way we check that. Um, and otherwise, let's put P in here. Maybe a remainder as well. Okay, we do get a bounded in there. Yeah. This isn't going to terminate early. That's probably what it is, right? So, how can we fix that? Right, let me just do a quick little test here. I think that might be what it is. Let's make f be a quick little recursive function that kind of simulates returning early. We'll do x, and x is, so we'll do, I'm going to do this on REPL quickly and easily. X's bang, okay. And then if I do F1, 2, 3, 4, that will return 3. If I do F1, 2, that will return error. Exception. No. But non-exhaustive, I don't know. Oh, because I redefined it. Diggity. Let me just write one here then. Of the function, list of int. We have the empty list. Let's just error out. Otherwise, we have x and x's. And we just do if x equals 3, then x else f of x's into the natural recursion. Okay, so if we do f 1, 2, 3, 4, we do get 3, and if we do f empty, we get woohoo, and same if we did f 3. Okay. Sorry, like say 4. Okay. Yeah, so that's right. So we when we get the found it, that should return there and not go to the natural recursion. All right, get to pure. And then so it's got to be, clearly we're not initializing the empty case unless there's a point where we are. Maybe because of the way the test is set up, the test data. Let's just look here, face down, use, just show them. That's not empty. That's definitely not empty. So it's another cell, maybe? It says should not end up here. So the sum of possible tile weights. Yeah, that's our sum total weight, I think. Yeah, you know, that's a very neat trick. I'm starting to think maybe I should just do this a different way. That's maybe not as like pool or whatever. The only other, maybe it's fine. Maybe it's actually implemented fine. What could be happening is that we are collapsing down to nothing. And then we go to a cell and try to collapse that one, and it has nothing in it. But how do we know that that's happening? Because we get here, I don't see P's empty before we hit this exception. We got found it. Found what? The P. $11. Okay, so let's, I think we could check that by, at the beginning of ClapSat, we can look at the cell possibilities of the cell that we get out of the waves from get cells. Let's pop that over there. Do that. Actually, no, that'll be here. Before we collapse a cell. Lots of possibilities here. The world is our oyster. P's reflects that. The next time we call it, we get some. It's like a lot of odd ones cut out. Alright. It's remaining. So it must be getting going 0, 2, 4, 6, 8, 10, 12, 14. This is where it's hitting it then. That's the only thing it can be doing, is that it's actually hitting the base case. It's not picking 14. So remaining is not getting decreased enough to actually hit our condition and avoid this end case, this base case that we're supposed to not be able to hit. That seems to be what's going on here. So maybe we're not calculating the weight properly. I'm not get the right value for weight. Or yeah, something like that. Okay, let's look at relative frequency. We have the generated frequency hints. We look up. The pattern index is an integer. We look in the frequency hints for that pattern index. We get either 0 or that value. 0 if it doesn't exist. Okay. It's pretty straightforward. So maybe we could be calculating those wrong. Let's get back here. Actually, put that debugging back in here. The alerts, you are banned. Bye-bye. Okay. Okay, so in the go case, I'm just gonna punt out the remainder in the wait. Okay, so the remainder actually starts off pretty dang high. And then each piece seems to be all 8. That doesn't seem right. We should probably look at the frequency hints for... Yeah, we should probably just look at the frequency hints, period. That's really easy to check. So it should be trace in, there, just like that. Okay, they are all calculated to 8. That seems fishy. Hey Goku, welcome back. How's it going? Nice to see you again. Okay, so yeah, it looks like the frequency hints are a little bit fishy there. I don't think they should all be 8. So the frequency hints are supposed to measure, like, how often a particular tile, like similar tile, shows up. So like the more similar tiles you have, the more likely it is that you'll pick this one for a particular cell. Things are going pretty good, Goku. Gotta say. The summer heat has turned down a little bit in my area. I've been skating a little bit more, which has been awesome. Without getting so schmetty. It's been good times. A lot of good programming, a lot of stuff to work on. And all good. So anyways, back to the frequency hints there. If they're all 8, that means like they're... That's just not right. They shouldn't be all the same. So I think in our test data thing, it is not that self-similar. This is our... So if you imagine this is a bitmap, like a 0 is black and 1 is white or something like that. And we're cutting this up into, what is it, 4x4s? Oh, actually maybe it is. Maybe we need to be 3. That's better, actually, yeah. Okay. Wasn't necessarily that, but problem with the test data. However, we're still not quite getting remainder right here. And then we are getting to a point where P's is the empty list. Okay. Yeah. 2 probably doesn't make a whole lot of sense. I think 3 makes better. It's better. Get to P's. Okay. So, let's see. Remainder is still getting initialized quite high relative to weight. So we're starting at 24 and weight, our frequency weights are still like 4. This cell total weight maybe is just too much. Possible tile weights, right? Let's get entropy calculation. Total possible style frequency. Looks like that's from remove tile and entropy. It doesn't. I don't think they show how to initialize that actually. Looks like. Definition, use. Here's add up all the relative frequencies. Relative frequency. Right, and that's how you get the sum of weight log weights. Okay. So initially, weight here is 24 because we have 6, 10, 12, 13, 14, 15, 19, 21. Say 20, that's 25, let's say 24. Maybe I miscounted there. We subtract 4, we get 20. We're checking weight 2. Subtract 2 from that. Get to 4. Maybe what we need to do to fix this is, if we get to the base case without picking one, we should just pick the last one. Alright, otherwise, there's probably a much simpler way of doing this, which is it's gonna ignore the weights, which is the unfortunate thing. But if we just picked randomly, that would solve it too. The only reason why this one's good is because it takes into consideration the frequency hints. Okay, relative frequency. Oh, Jesus. Pardon me a second. All this back and forth. I use an inverted, inclined keyboard tray, and my stupid mouse pad has been. It has this little edge on it to catch the mouse, but I keep missing it. Keeps sliding around on me. Anyhoozle. That might maybe work. And then we definitely couldn't hit this case. The other thing I was going to look at, frequency. I'll give a definition for. This turns the number of times the corresponding tile appears in the input. This corresponds to the weight of a possibility in the simplified entropy equation. That could be a thing too. But I think this code that I wrote here is just assuming that this was like just the frequency hint value. Oh no, let's see. Yeah. So just literally looking up the frequency hints and getting the frequency hint value, which is probably not quite. It seems like we need to do a calculation there. So we need to look at the number of times the corresponding tile appears in the input or pattern. This corresponds to the weight of a possibility in the simplified entropy equation. So if you have an unknown value of n possibilities, each probability can be represented by that. And the above entropy equation can be simplified in practical terms. This is the case of discrete probability. Okay. W be the sum of all weights, then the entropy of the unknown value is this. Okay, so that's basically going to plug in here. Take the sum of all the weights, plug those all in. Sum of weight 1, W1, W. Take the log of the sum of all weights minus W1 times log of W1 plus W2 times log of W2 all the way to log of W1 divided by the total weight. So how does that handle with relative frequency? Does it mean like weight of a possibility means we just pick that one possibility, do the log of that weight, minus the log of that weight. We just pick the one of these? Maybe? Is what they mean? Alright, let's try that and plug that in. Okay, make this a let, and we get the X hint. Frequency hint. Okay, so we get that. And then we need the sum of all of them. That's total possible tile frequency. And total weight. Okay. Don't quite want... no, we want the sum of all possibilities in the frequency hints. actually. Let's apply it here. Use that in 2 places, so we'll find that as well. Yeah, we'll pop that over here. Array. Get the sum of that. We can get the array of soaps, the association list. We'll take the second elements from all the tuples of that, and we'll sum those together. Except it's not, it's a map, isn't it? And so that would be map. Association for that. Okay. It's not integrating. Okay. And then we want to take this log of sum of all hints. Subtract that from our current log times the log of our current log. Excuse me. That's our X frequency hint. Log of X frequency hint divided by the sum of all hints. Probably going to want truncating division. And that's probably, yeah, floating problem. No, it's just a floating int. Oh, take floating a sum of all hints is an integer. We need a function. It's int. Oh, okay, that's why. It's, I'm... Something in here, in this expression, is not forcing the right thing. That should be int as well. Int. Int. What the log? Oh, what am I doing wrong? It needs a floating A for log. Google. From the integer. That's what I think I was going for. And this one is going to need a little help there. Ah, come on, what is it here? Haskell, it's kind of a weakish. It's a good. Oh yeah, but I don't know. Haskell numeric sometimes annoys me. So obviously that's going to return a floating A, so we have to ultimately return that with to integral. Or to integer. From integral. Yeah, it's annoying. Doubled int. Okay. So we need a double int here, so we can go like ceiling or floor. Let's just go floor, truncate off. Okay. So that part's fine. Now we need to subtract that x frequency hint times the log of the from integral sum of x frequency hint. And this is still going to be unhappy. The type of this sub-expression here. Might be here. Yeah, okay. Type defaulting, I think. That's that part. And then that's not going to be quite right. Yeah. Yeah. Okay. I think that maybe that's it. Not quite though, because we're getting not good values for weight here. Or remainder. Down to the weight of a possibility in the simplified integral. So maybe it literally means just this value here, a particular weight. So let's get rid of all that and that. Let's do x frequency hint times log of the from integral x frequency hint, and we floor this whole thing. Yeah, tech defaulting. I know. I just want to see if I'm getting like better numbers here. Okay, 5.5. That's better. Still getting there. We're still getting to the collapse too. Which... yeah, I think if we jump back over to here... nope, not like that. That way. Okay, we're getting 19, 18, 13, 6, wait, 1, and then boom. Yeah. Hey, TwitchD, how's it going? The wave is still collapsing. We're debugging the function that picks which value to collapse a cell to, so that it takes... so that it uses the frequency distribution of the tiles, how frequently the tile appears. It takes that as a weight. Frequency hints is fine. I should probably actually echo everything. Probably help. Not much, but... yeah, no. Super TwitchD. And hey, I'm happy to take backseat programming or questions and diversions too. So feel free to lurk or whatever's. Okay, so we find 8, but then we go to initiate with the empty list. So if we find 8, and then somehow we're coming back into collapsing another cell. We're calling collapse out again somewhere else. Let's debug.trace the parameter we're given here. Yeah, so I think we're going to another cell, and for some reason that one has no possibilities in it. Yeah, so we're going to 6.4, starting at 9.9, and for some reason 6.4 has no possibilities off the bat. But it looks like we do get to pick a value. So I think that part is good. This, I think, is indicative of another issue. So we're making progress here, but found 8. I just want to make sure that in collapse at, when we go to collapse this cell, we pick 8 and we set it to 8. And The new possibilities for this cell are just those. So collapsed. So when we create the new grid, we set this at the cell index, the new collapsed cell that we just created. We initialize the pattern stack, and then we set that wave state grid as the new grid for the next state. Okay, so let's take a look at what collapsed cell is. Why did I pick the name Agent Ultra? You know, it was so long ago. I don't know. I picked a domain name back in like 2007 for a new blog I was starting. And it sounded cool, I guess, at the time. Can't remember why, though. It's getting close to 20 years now. Which is crazy to think about. Yeah, agentultra.com. Find it all out there. Yeah. Except I wasn't in high school. It was still pretty cringy. So are you saying Agent Ultra is pretty cringe? Is that what you're saying, Twitch? I mean, it kind of is, but whatever. It's all good. Young me was a pretty cool person. Yeah, I mean, it was like mid-2000s, so it's definitely of its time. When people still made their own personal websites back then, and this was like your social network. You know? Now the internet is just not what it used to be. Not even close. Better in some ways, though. Like video, for example. I was watching video online on the internet back in the 90s, but it was like a tiny little box. Watching a stream on it, you're like, oh wow, I'm actually watching TV on the internet. It's terrible. But yeah, I agree. Modern internet is not quite the same. It's been turned into a mall. Maybe worse than that. Not even a mall. It's like a curated experience. And yeah, very different than what it used to be. It's almost, using the internet these days is almost like you gotta be either oblivious or like adversarial with it, because it's always trying to get something out of you. Which is a shame. Okay. Yeah. So we find a value, which is good. I wanted to print out just to make sure that what we collapse to actually gets picked for the cell and gets back into the state. Oh, phones are the worst, man. I don't know what I'm gonna do with my phone. So I'm still rocking like an old ass, well, up until fairly recently, an iPhone 7. I was keeping that thing alive with like aftermarket batteries and screens. And recently it got so total that I got a loaner from a friend, an iPhone 8, which I'm like, okay, this is great. But they were like, here's an iPhone you can borrow. The new 16s are going to come out. You can use this as a loaner until you can buy a new phone. Okay, cool. And I'm looking at the new ones that are out now, and I'm like, I just don't want it. You know, but there's nothing else on the market, really, that I know of yet that has, like, enough to it, enough going on. But I just don't want all the AI stuff they're pumping into these things. I don't need a super powerful GPU and all of these features, right? I don't know. I may end up getting one just because, like, the obsolescence kind of... I think they just support them for like 10 years or so, which is pretty okay, but... I don't know. Yeah. If you can turn it off, that would be super great. It seems weird to buy like all of that equipment and not use most of it, and not even want most of it, so I have to do something about that. So if anybody in chat, like Twitch, any of y'all know good iPhone alternatives. I mean, it's not so much the data privacy stuff, although that's really important too. I just don't, AI stuff is just garbage to me. I just don't like those features. Yeah, Apple Intelligence, right? I'm like, I just find all those kinds of features kind of garbagey. I just don't like them. I don't want it rewriting emails for me. Like, I know how to write, and I'd rather write in my voice than sound like a Karen. You know? Or stuff like that. And I know it's all done on device too, but like, how long until the 16 is jailbroken, or that there's like 0 days into them? I don't know. Pretty valuable database is being built by these things. Encrypted at rest, sure, okay. You know. But, I don't know. I'm not going to use those features, so I just don't want them. Yeah, maybe. Yeah, I just don't want those features. Like, we can barely get autocorrect without these fancy models to work well enough that it's not annoying. I just find them garbage. I just don't like them. I don't think they're good. For me. You get in my way more than help. Anyway. Okay, so I think this code is okay. Yeah, we're gonna print out, sorry, the updated style. Just to be doubly sure. I might not be able to print out a collapse style. I don't know if it has a show instance on it. I guess the GHC will let me know. Yeah, it does. Super. Oh, Windows recall is the worst. They have time to fix it before the EOL Windows 10 and like force us to have it. Oh man, I hope they smarten up. Okay, so I wanted to check the cell possibilities to make sure that the one we pick is true. That's 8. False, 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 false. We get just 8 here. That's good. Okay, that's good. This isn't looking so good. Yeah, I'm writing out Windows 10 too. I'm not looking forward to Windows 11. Like, this is my streaming box. I use it for gaming sometimes, and that's about it. And for like if I'm doing cross compiling for like when I'm doing game development, I can cross compile and run on Windows just to test out that stuff. But otherwise, yeah, don't really use it. But I can't even run Windows 11 on it apparently. So, buy a new computer, I guess. Not really sure what I'm going to do when I'm going to be forced to upgrade or run something else on it. Well, and I do like some, like when I make music, I do some touching up stuff and things like that using some of the software here. But yeah, anyway, meh. Yeah, I don't know what I'm gonna do when I have to upgrade. That's gonna suck. But this is like the final stage of capitalism, right? It's like, okay, it's a crap. You're locked in, so we can make it as shitty as we want. What are you gonna do about it? Yep. It sure is Monopoly money. Okay, so that's looking pretty okay, except for the NAND there. I'm not a huge fan of that. Just dump that in to file. Speaking of the old internet, there was a time when computers were good. Neat. Sucks how much they've been made pretty shitty. Over the years. Okay, I mean, it's not all doom and gloom, but like, I don't know. Could be better. Alright, so that's kind of getting updated properly at least. So I'm happy with that. Happy with this part. Take that out. So the next part is figuring out how we're initializing keys with no empty patterns. So that looks like more of an possible initialization issue. Right, because when we collapse this and we pick one, it picks down to one value. In the propagate step, we could be eliminating that one value, or all, potentially, if we made a seriously bad boo-boo. Somewhere in this. With that one, and down. It'd be weird that we initialize one cell properly and not another. Okay, so that one gets collapsed properly. It's when we go to collapse 6-4 that there are no possibilities remaining. Okay. We call collapse at once here, then we call propagate. Do we ever expect not a numbers? I don't think so, which is why I think that one's probably a bug. All right, that field comes from this actually pretty clever idea from this blog, which is to cache this caching section. I thought this was a pretty super dope idea. And it explains it basically, and we've covered this early on the stream, early in the series of streams, when calculating which tile to pick next. So we have like the whole grid. Let me draw this out a little bit. So we have like the whole grid. And the idea when we collapse a cell, and if you imagine each cell is like a stack of cards, right? And in each cell, we have all the possible cards that we can pick, right? And the whole grid is set up that way. So then we pick a particular value for one element in our grid somewhere. All right, say like right in the middle. Okay. So we remove all of the cards but one. Okay. Now using our adjacency rules, right, there are cards in the stacks next to it in the orthogonal directions that need to be removed, that are not possible to pick as potential cards to place in that particular cell based on the adjacency rules. So like there's many that can't be south of pink or below pink, down from pink in this cell. Right, there's ones where pink is allowed to be above, and those ones can stay here, as well as the ones that to its left and right. So we basically have to like filter through that stack and go through the rules and pick those ones that you can't pick. They aren't allowed to be able to remain out. Right? And once you've done that, and you go to propagate out. Right, so now you've eliminated a bunch of cards from here, and so you have to go to the other stacks in its orthogonal directions, and also remove, and so on and so forth across the whole thing. The thing is, which cell do you pick to collapse next after you've done this whole wave, you've kind of done all this propagation, and you've removed a bunch of cards? Which cell do you now pick to eliminate, to collapse? Right. And so the idea is, yeah, you could pick randomly, right? And I guess the original author of wave function collapse said that, and I'm not sure if this is true or not, but they claim that picking randomly leads to a lot of contradictions, or a lot more contradictions than if you chose a smarter method. And a contradiction is when you can't collapse down a cell to a value because the rules forbid you from doing so, right? Or you need to propagate out a rule and remove a card, and there's only one remaining in there, and that, so you would eliminate that one and cause contradiction. So the idea is that you pick the cell with the lowest entropy, which is basically like the fewest remaining cards in its stack. Basically. And so you could calculate entropy, the remaining entropy after calculating the whole wave, and go cell by cell through the whole grid, calculating the entropy, recalculating the entropy for each cell. The cool idea here is that doing that every time, because you're going to be doing that a lot, is very expensive. There's only a couple of times when you need to recalculate that value. That's usually when you change that cell, right? And you collapse it down. So this whole section is about caching that down to a caching the parts of the entropy calculation in the cell itself. And then when you modify that cell's remaining values, you update the cache. So you kind of do it only when you need to. I thought that was a pretty cool idea for that. But I don't expect this value here to be a nan at any point in time. So it means like my code is messing that up somewhere. Yeah, that's an interesting idea. So yeah, like assertions. I was thinking of that a while ago. Like, how do we add a good approach to adding like kind of those sorts of assertions into Haskell code and Haskell programs? That's a pretty good idea. So float, we had a float without nan. Yeah, it's almost yeah. You're right. It's not an assertion, but not nan. I don't know. Naming's hard. Okay. Yeah, let's tackle this one. Okay. I'll put it down here somewhere. Call it. What happened? Music here. We'll call it actual float. And we can guard it. I think we have. So new type is interesting. Let me take a little diversion for that. It's pretty simple. All right, so the idea is you get like, we used to just have like type aliases. All right, so you might use a type alias to kind of distinguish in your code that like it's not just any old float that we're interested in, or it's not just a string. It's something that means something, like the value means something to our program, right? So we give it a name, we give it an alias so that we can indicate in our types of our functions and stuff that it's not any old string, it's like a date or whatever. The problem with type aliases is that they literally just mean they're interchangeable with the actual like basic type. And you can't hang instances and stuff off of them either. So they don't really help you all that much. New type actually creates an actual new type, right? That has a constructor and has a value. And so if you wrap, say, a float with a new type, like we're doing here, it is essentially a float, but it's wrapped in this new type wrapper, this constructor, and is treated like a completely new type. So you can't mix floats with actual floats. GHC, though, under the hood, and I think most Haskell implementations under the hood, are expected to treat actual floats and kind of unwrap them to be just floats. So there's no performance overhead for using them. And another nice thing about them is you can hang instances off of them. Yeah, I was having a debate with some folks at work about this, and I think I'm on team, like, new type should just be type. And that's just how it should be. But that's what we have. How do I test for nan in Haskell? I don't feel like I can do that. Nan. Maybe it's in float, the float class, or floatable. How do we test for naness? Is there a constant? Reciprocal fraction floating A. I don't know. Oh. Oh, there you go. Is nan on a real float? Interesting. Is nan X? That doesn't work. It's not real float, actual float. I think we can derive that. Strategies right now explaining all that. A real frac sign. I just want to drive those from the org. I'm just going to keep adding instances until this goes away. As long as it'll let me. Okay, real float. I swear it's a real float. Oh yeah, I remember when Watt came out, man. I was there. Yeah, tuning's always false. Yeah. And we're using isNaN. I actually have to derive all of those to get actual float. There's probably an is class or something for that, or new type deriving type thing to get that. These are all like just really annoying, like just numeric type classes, and not some of them are not numeric type classes. Like if I can probably get rid of these and just unwrap the X. And then not have to do all that. Okay, so yeah, this is more like is actual float. And then we can just do a... And then we can have, like, we can still construct actual floats using the constructor here. Or we could do a smart constructor that way too. Yeah, this could be just float. We have to wrap that. We don't really need the new type on it either. Yeah, so it's like a common pattern in Haskell is like smart constructors. This is not so smart because it's just throwing a runtime error, but yeah, we could do like maybe a float, but that's fine. I kind of want to throw a runtime error. I'm not sure if we'll keep this in the final implementation, but it's good enough for finding that bug. Okay. Underused. But not underused on this stream. But as you can tell, in Haskell, runtime errors don't have a lot of really, like, good support yet. And Haskell just kind of panics and doesn't give you like a trace back and stuff like you might expect if you were using something a little bit more dynamic. And it kind of makes sense because like a lot of Haskellers want to write code that like doesn't error at runtime like that. So like the surface areas of those should be very, 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 very small. And so when they do happen, it's like holy cow, how did that happen? In production code. But the stuff I'm writing on stream, I'm writing for learning, so I don't really care that much. So how would you use it more or better? You like the idea of types is amazing, but you think the implementation in general is terrible. I think the implementation in general, at least in Haskell, is pretty good. It's not the best, but it's pretty good. It's practical. It's pragmatic. I think there are better systems out there or coming, which is exciting. I think it's good. It has definitely changed the way I think about programming, though, quite a bit. So when I go back and do stuff in C or whatever, I find just the way I approach things is different because of it. Okay. So then with actual flow, now we can go to the place that we're doing the caching stuff, and we can use the smart constructor to try and catch where that stupid nan is coming from. Wait log wait. So this value here is responsible for generating that value. So I'm going to change this to actual float. Right, and I can stick this function in front, and that should catch. Okay, well, a few places where we're expecting float, but we get actual float now. And these kinds of things. So jump over there. So our definition of cell wants it. Get rid of that. We need econ show instances on it. And then the entropy calculation. So wait log wait. So we need a way to get the unwrap the new type out of this. So the way we can do that with new types is that so the one rule about new types is they can only have one value. They can't wrap struct or anything like that. But we can make a little function here. We'll get actual float. Now this function that it's generated has an applied type of get actual float. Actual float is the first argument returning float. So yeah, it's got to be 1-to-1 so that it can do that unwrapping unboxing business under the hood. Okay. So pop back up here. Bigger type, that would be great. Okay, then we have some literals in the test code for it. That's no problem. We can fix those. That one. That one. Actual float. Here. Here. Sweet. Switch. Switch TD, man. That's great. Okay, so this is kind of what sucks. This is all you get. Like in this case, it's fine because it's not a very complicated code, but it's very Spartan. So I'm curious how we can better utilize runtime errors. Maybe with more pervasive use of call stack, Haskell stack and stuff. We can get those call stacks back in. Oh no, what do I do? Beep, 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 beep. Right, so it's like pointing the rate where the error is thrown, but like, I mean, there's only one place we call this, so I know where it is, but that's still kind of a drawback. You got to put has call stack everywhere. Okay. So it's in this calculation here that we're getting an and. Either in the sum or in one of the log weights that we map. Now, relative frequency. That returns an int, so we convert that to a float. Log base 2. That looks sus. Looking sus. Sussy looking code. Yeah, it's probably not what we want. Yeah. See, it's kind of the opposite approach to like correct by construction and like stuff, which is what a lot of Haskellers really push for. So it's an interesting take. I think that's kind of neat. Personally, that's usually where I try to take things, but it's really hard with algorithmic code, especially if you're like monkeying and aping somebody else's code, trying to translate it into Haskell. So this log2 function, I'm not sure log base is actually log2. I know we go log base 2.0, but I think log base is something else. Where is it? Ye old Hugel. Somebody must have written a log too. Math function, bits, kryptonite. Pretty sure I can just steal one of those. It's using libgmp stuff, which I think on most platforms is available where you have GHC. Libgimp, yeah. That's totally the problem, Twitch. They IEEE 7, they're not reals, that's for sure. As long as that's probably ellipse. What is that? A library specific thing. Otherwise, this default implementation is probably fine. This is like probably like a wrapper for libc. Like if you've got GMP directly, use that. Otherwise, use this crappy one. I will take crappy one. BX, so we could just replace B with 2. That's just 4. Two. See if I did that right. Oop. Missed a B. I didn't do it right. Let's say it's you don't like this. Oh, that's not how you type that. Need a fat arrow. Ooh, that's why it needs. That's why it needs it. Okay. I'm gonna undo all that. Put that all back in the way it was. This, like this, like this. And then I'll just go log 2 like this. Yeah. Probably need some type annotations, yeah. Integer to int. Okay, so then an RF, so we take the from integral of that. Because you want to be an integer. So we actually don't need to turn you into float there. Oh. So stupid. Formidable RF log 2 formidable. Formidable. Okay. And yeah, what else are we missing here? I think that's where are we at? No, we're still. Oh no, couldn't find it. Collapse 2. 3, 7 now. Okay, so potentially fix that. I realizing I haven't committed a whole lot of code, so this is gonna be like one kind of big messy one this week. Yeah, I mean, in our work code too, like I do a lot of fintech stuff, and we have a lot of like sized types, which are kind of annoying to work with in Haskell, to be honest. It's one of the things you want to be able to specify in some cases where you're like, and I think we published this package actually, where you want like a non-empty text. I think that's, I can't remember which one's the one that we do. No, I don't think it's this one. Anyways, we have a module kind of like this, but it has a bunch of other ones where you have like not empty, non-empty text. So like it's not just spaces. Maybe we haven't open sourced it yet. I don't know. But the idea is, anyways, you have like these kind of types where you want like just positive integers or non-empty, like I was mentioning, non-empty text or non-empty, not blank text or text non-empty text less than 99 characters. Well, type systems are built for humans in mind who understand how to model things in terms of types, right? But expressing some things, yeah, can be pretty tricky. The thing I think we're struggling with at the moment in terms of like type stuff is like dependent types where you could totally specify that at the type level, and you might think you really want to, and that you should, and now you have the power to. But I have this sneaking suspicion that we're not terribly great at simply typed stuff, and you can really tie yourself into a knot with dependent types and like overly specifying things a little bit too much. So I think there's a balance to be had between specifying everything in the types and having, like we were saying earlier, like maybe some more runtime type error, like runtime errors or validation. There are like strategies to avoiding it. Because like I don't like runtime errors that much, but you know they happen. Yeah, there's a balance to be struck. Anyway. So that's that. Let me just commit what we have so far then. We'll apply this change. We'll fix errors in relative frequency elsewhere. Right, exactly. We're typing sorting algorithms becomes a PhD thesis. Exactly. All right. It can be useful in small amounts, don't get me wrong. But I think what we really need is like an industrial scale, like ready to go dependently type system that may not be perfect, but is good enough, and just let people have at it. to find out where that line is. But there's a lot of humming and hawing about it, and like it's hard enough to get regular programmers who are not familiar with Haskell to try Haskell even. So getting there I think is going to take a long time. How so, TwitchD? I am curious. Do you have ideas on how it would be better approached? Where we should experiment with? Because maybe we could try it out on stream sometime. Unless you already have a project you want to show it, that'd be great. By all means. Okay, so the next part that we need to fix is back to this initialization issue. Okay. You know what? It's running late on the stream, so I may not be back when you get back, Twitch. But I'll try and hold out. But if I don't see you, have a good one. Okay. Yeah. So on that note, actually, I'm gonna cut it here because I don't want to. If I get into this, we're gonna be here a while. Okay, so we just have to fix that. So I'm gonna go back to my to-do file. I'm gonna mark this one as done. This one isn't done, but it's changed. There's Sal not being initialized. With any possibilities? Or so it's either it's being initialized without any possibilities, like when we construct the wave state and we're not doing it, or propagate is eliminating all the possibilities from a cell when we go to collapse it. So there's something there. A little productivity tip sometimes when you're going to go finish the day and it's getting close to, you know, whenever you're done work, you haven't quite finished everything yet, leave yourself a broken test or a broken type. So when you come back the next day, you'll know exactly where to start. You'll just kick right in and get going on the ground running. Anywho, that's all I got for this week. Thanks for watching and hanging out with me. It's been great. So if this is your first time tuning in, again, there's that word again. More people were tuning in. If it's the first time watching, thanks again. You can find all of my socials on Mastodon here, links to my website, YouTube, where I back up my streams, and my website and all that. It's on Mastodon at the types.pl server at Agent Ultra. All right, the code that you've seen here tonight, I'm going to push that up. It's all on GitHub. I'm Agent Ultra there as well, on wave function collapse. Okay. You know, like star, whatever. Maybe you got 0 stars, so super popular. And what else? That's about that. So links there. The link above my head goes to declarative.tv. there are cool people there who also stream stuff in other programming languages, including Haskell, that you might be interested in following and checking out. There's also a Discord server on that website. There's a link to it, at least. And you can go chat on our stream channel there if you would like to do that sort of stuff. And I usually do these streams once a week on Tuesday evenings, so if you want to follow or just write it down in your little notebook, or if you're watching on YouTube, give us a subscribe or a thumbs up, all that sort of stuff. You know what to do. And you'll get notified when I go online and do these streams, right? So may all your monads be free and your types always checked, and we'll see you next week. Take care. Happy hacking out there.